I'm going to show you how, if you can't do A, don't forget you could usually do B. It's usually easier. So I'm going to do B first and get that out of the way. So evaluating this, I'm going to just put an equals there. So I can use the reduction formula that we've got here, and if you have a compare it to this, we've got n equals 5 for this question. So we've got I5. So I5 is going to be 2 on 5 minus 1, and then we're going to have sine 5 minus 1 pi on 3 minus I3. All right, so I need I3, so this is just half sine. Now 4 pi's on 3, so if I'm looking for pi's on 3, that would be over here, 4 pi's on 3. This is 3 pi on 3 and a 4 pi on 3. So all stations 2, so sine is negative here. So I'll put this straight in here. Oops. So sine 4 pi on 3 is minus, why didn't that disappear? Minus sine 60 is root 3 on 2. Alright, so I need I3. Let's just put it straight in here, why not? So now if I look at I3, I'm going to have 2 on, 3 minus 1 is 2, sine 3 minus 1 is 2, so 2 pi on 3 minus I, taking away 2, so I1. So here I've got minus root 3 on 4, minus, oops, I don't need that. Alright, so that's going to be a minus 1 and a sine 2 pi on 3, which is over here, so it's going to be positive. So we've got, I don't need to do that, so root 3 on 2, and then the minus minus, so we've got positive I1. Now what is I1? Let's just quickly find I1. So I1 would be cos x, sec x, so that's cos x on the bottom. So it's just 1, so we're doing x, sorry for the bad working here, between 0 and pi on 3. So obviously it's just going to be pi on 3, if that's 0 and pi on 3. Alright, so if I1 is pi on 3, that's going to be pi on 3 there. Alright, so what is my answer then? I've definitely got the pi on 3 as the positive part, and then I've got minus minus. So if I double that to make it 4, and I double that to make it 2 root 3, so I'm really got negative 3 root 3 there on 4. Alright, so that's your answer. So B, quite straightforward. The reduction formula makes it easy. You just have to follow it through. Alright, so A, probably a little harder, but let's try it. It gives us hints in the question. Actually, it gives us hints right here. So we're supposed to write nx as n minus 2x plus 2x. So using some sum to product to sums here. Alright, so, if I do that then, my in is going to equal, so I'm going to break it up. Actually, I'll just, before I even go there, I'll just break it up. So inside here, I've got cos nx, which I'm going to make n minus 2x plus 2x here. So, yeah, so I don't know what I said before, so compound angles here. So if I expand that out, remember I get cos minus sine sine, so I'm going to get cos minus sine when I expand it. Alright, so really that's for the cos nx, so I'm just putting a sec x with each of those, right? So I'm going to be multiplying this one by sec x and multiplying that one by sec x in order to get back to my in. So if I write them separately, the other thing I'm going to do, or will I do it now? The other thing I'm going to do is make my cos 2x. I'm going to use an identity there, and I'm going to do a 2 cos squared x minus 1. And then, because then I can expand that out. And for sine 2x over here, I'm going to use the identity 2 sine x cos x, because I want some cos x's with my sine x's there. Oh yeah, actually, and that cos x is going to cancel with this sec x, so maybe I don't want some cos x. So let's have a look at what we get. All right, so if I now put that simplification into my integral, so my first one, if I multiply using this term first, and then I'll do the minus 1 second. So what am I going to get there? I'm going to get the cos n minus 2x, and I'm timesing by cos, and so one of the cos squareds is, I'll put the 2 out the front, that'll make it easier. One of the cos squareds here is going to be cancelled out by a sec, so it will just be one of the cos x's left. Alright, so in the second one, I'm doing the integral of, and so, well, the sec x is going to be there, because this is where I'm timesing by -1 for what's there. So I'm going to get a cos, here we go, n minus 2x there, dx. And that is our I n minus 2. So really that's just I n minus 2, which is handy to note. Alright, and then over here, I've now got minus, I'm putting the 2 out the front. Alright, this is going to work out nice because I've got sine n minus 2x sine x dx. Oops. And that's 0 to pi on 3. Alright, so you note that this is nice because both the first and the third term both have 2 out the front. And they both have the same angles. They've got the n minus 2x and the x. So you can think we can put them back together because it's a cos minus a sine. So we know that comes from a cos of the first angle plus the second angle. So actually I can rewrite those, the first and the last integral together, if I put them together, as cos of n minus 2, that's the first angle, plus the second angle, x dx. And I've got that minus I n minus 2, I'll write that here, minus I n minus 2 as well. Alright, so this we can integrate because cos we know goes to sine, and of course this is just n minus 1 when we simplify it. So we're going to have cos n minus 1x, and we're going to divide by n minus 1. And this is between 0 and pi on 3, minus I n minus 2. So what does this give us? So I'll put that n minus 1 out the front. When I put 0 in, you can see it's a bracket times 0, it's going to be 0. Sine 0 is 0. So I just have to put the pi on 3 in here. So I'm going to get sine n minus 1 of pi on 3. I can put it on 3 like that. There we go. Minus I n minus 2. Oh yeah, so there we go. They haven't put brackets around theirs, but that gives us what we're looking for. Hope that helps.